Imagine losing 100 football fields of mangrove every month. This is Sundarbans today. But what if satellites and drone could fight back? So here we are, Team Maddox Fusion from NIST, Odisha, and we have built India's first AI shield to save these forests. So let's quickly come to the problem statement. The Sundarban mangrove forest is facing rapid deforestation due to illegal logging, aquaculture expansion, infrastructure development, pollution, and climate change. This degradation threatens critical biodiversity, disrupts local livelihood, and weakens natural defenses against cyclones and sea level rises, demanding urgent conservation and sustainable management. The Sundarbans feeds 4 million people and shelters the last Bengal tigers. Yet illegal loggers and climate change are shedding this green fortress. Behind these numbers are vanishing tiger habitats, eroded coastlines, and ruined livelihoods. In normal conditions, manual patrols miss 80% of deforestation, and paper evidence rarely convicts loggers. So, this is a war. Only technology can win. So, the most basic and important question, can, can AI outsmart illegal loggers? Let's find out. So, here's our proposed solution, AI based deforestation reduction system. So, the first basic question, how is it efficient? So, to answer to that, when in normal condition patrollers find out illegal logging or some other deforestation conditions, they will get to know about 30 days or more than that. But our proposed solution can detect and give the alerts in only 90 minutes. The AI-powered deforestation detection system is an automated monitoring system that uses satellite imagery to detect deforestation in the Sundarbans. When significant changes in vegetation are detected, the system alerts stakeholders and deploys drones to the specific coordinates for detailed inspections. So let's quickly go to the workflow and understand how this our solution works. Here's the workflow on how our proposed solution works. So our very first step to the the solution we have proposed is we will have the satellite to give the input data to the software. The data will consist mostly of the images the satellite will capture, and it will transfer it to the software where the machine learning algorithm will process the data or the image, and upon processing it will transfer the data to check or flag those which are suspicious areas, and upon flagging those areas it will notify the host and auto launch the drone. The drone will take the GPS or Navig coordinates and will go there, and simply by using camera and telemetry it will capture images of the real time, and upon capturing those real time images it will confirm that if something suspicious has happened or it was just a blunder. So it will generate alerts and notify the host, record event and data on blockchain. If something illegal is happening, it will keep the perfect evidence for those to justify, and analytical reports and visual graph in will be hosted in the dashboard. So let's quickly proceed to the software prototype that my team Adox Fusion has created. It goes by the name Sundarban-watch.versal that app. So this is the we can say the loading page or the landing page which we will land upon going to this website. First, we are having the dashboard, forest map, alerts, reports, and drone controls, in which it will show the total area which are monitored and the zones which are monitored, and will give the alerts which are active, alerts which are not resolved. For example, here can you see active alerts? It's showing 3, and it will also show the drones which are deployed, which you can see the number. Now let's move to the dashboard section of the page. Here you can see the workflow of our first step, that's the monitoring by the satellite image. Here you can see that Using the satellite data or image, we have flagged the suspicious areas and generated the alert which are in critical high deforestation rate. Here you can see the flag surfaces area. For example, you can see the first one is green, second one is green, and third one is yellow area. The yellow one is the most deforested part, which is denoted by the color of it, and we will raise those alerts and we will post there to for the drones to get the coordinates and to know which part of the image is or the coordinate is needed to be rechecked by the drone. And upon checking and analyzing those data and rechecking, it will post the reports. The reports will have the average health index, total tree counts, average deforestation rates, and total alerts, which we can download and print it if we want for further requirements. And now let's proceed to the drone control section, in which as the drones are mostly automated, but if the host want to control them manually, they can simply control the drones, and which and here they can check the uh, specifications of the drone, like they are charged or uncharged, they are available or they are on to check those suspicious areas and many other things about the drones and other parts. So let's quickly discuss about the hardware prototype that my team has designed. That is a drone. For our own requirements, we have designed on our own accord. So let's discuss for some part of it, like camera and feed. We have 5 gigahertz FPV live video, stabilized gimbal, and we have integrated GPS to it for precise location, which we will change to Navic if if we will be given access to that, and further more kind of increments will be done. Now, the most important question: how will the drones work without internet in those Sundarban areas? As it's not possible to have internet connection everywhere on those forests. So here's our approach. Our pre-mission setup will be we will upload GPS risk zones using USB or Wi-Fi to drone when it is connected to internet. For example, if we are going to install an drone tower which is connected to internet, it will with the help of that station or that tower, it will catch satellite maps and AI model using SD card. That is the while it's connected, and upon getting those GPS coordinates, drone automatically flies via GPS or Navic, captures 4K photos or videos and stores it locally. That is the on the SD card. And upon uh, getting back to the station or the tower, it will auto upload data at base when network available. Hence generates timestamped reports with GPS coordinates. Now, the answer to the most important question, why we are doing this and who will be our beneficiaries, who are going to get benefited, and who will be take the most efficiency of our prototype. That is, the first part is benefits to government agencies like MoEFCC, FSI, state forest departments, CZMA, NDMA or SDMA, National Biodiversity Authority. For example, let's check MoEFCC. Uh, it for real-time mangrove health dashboard for policy making and CRZ enforcement. MoEFCC will benefit by this, like real-time mangrove health dashboard for policy making and CRZ enforcement. Then comes to the FSI. by augments existing forest cover analysis with high frequency AI driven data. Then State Forest Department by automated alerts for illegal felling, enrichment or fire risk. CZMA, Coastal Zone Management Authority. It verifies compliance of industrial or construction projects with CRZ norms, NDMA or SDMA. Enhances cyclone or flood modeling by tracking loss of natural coastal buffers, that is the mangroves. Then National Authority (NBA) tracks ecosystem degradation in biodiversity hotspots for specific species protection. And then let's come to the second part of the beneficiaries, that is the benefits to security forces. The first beneficiary to our security forces is Indian Army itself. By terrain intelligence in border mangrove regions for detecting unauthorized crossing or camps, we will help Indian Army. Then comes the BSF, early detection of cross-border movement or hidden paths used by smugglers or poachers. Then comes our Indian Navy, by surveillance of coastal areas with minimal physical patrol burden, monitoring of naval-based perimeters. Then comes the Coast Guard, by identifying of illegal fishing or docking activities within ecologically sensitive mangrove zones. Then our DoD, by integration of AI-powered eco-surveillance with other smart defense systems or UAV platforms. Then comes intelligence bureaus, predictive alerts of potential threats or suspicious activities in dense, hard-to-patrol mangrove areas. Now, let's come to the third section of beneficiaries, the international organizations. The first international organization which we are going to benefit is like UNEP, UNDP, or FAO by verifiable impact data on mangrove loss or protection for grant monitoring and SDG tracking. Then comes the World Bank or ADB, real-time project tracking for mangrove reforestation programs they fund. Third is Global Mangrove Alliance, cost-effective, scalable monitoring across countries using a unified platform. Fourth is Blue Carbon Initiative, AI-powered validation of blue carbon project for climate report and trading. Now, here comes the fourth beneficiaries of our project. It will be like benefits to the academics and research institution. How? Institutes like IITs, ISRO's labs, and all the others. By accessing them to high-resolution mangrove chain datasets for ecological or geospatial studies. We will provide them mangrove chain datasets for ecological and geospatial studies. Then comes the international universities. We will collaborate research in AI plus climate with live project data from India. Third is ecologist. By long-term mangrove phenology and ecosystem response studies using AI timelines. Here comes our benefits to finance and insurance companies. For in the type of area we can apply this and what benefits we are getting, like risk and assessment and modeling. By improved accuracy in flood, cyclone, and storm surge risk model using mangrove health as a resilience factor, we can provide risk assessment and modeling. Second is premium pricing. By enabling a dynamic pricing based on mangrove buffer condition in insured regions. Third is climate-linked insurance. It supports parametric and micro-insurance models with real-time ecological data inputs. Then underwriting support enhances underwriting precision for coastal properties, fisheries, and agriculture. Then comes claims validations, satellite plus AI data used to verify actual environmental damage during disaster management. Then comes product innovations. It allows creation of new insurance product tied to ecosystem protection or degradation triggers. Then comes ESG and compliance alignment. It helps ensures align with sustainable development goals and regulatory climate disclosures. Now let's talk about the feasibility and viability of our project. So we have stated some problems and we have given some solution with our own project that this particular project will help. For example, the first problem is unmonitored and illegal deforestation in remote parts of Sundarbans. How we will deal with it? Like we will use satellite imagery and AI to detect forest cover loss in near real time so that a real time action could be taken. Second, delay in identifying and responding to deforestation activities. We will automatically alert authorities and launch drones for rapid ground level verification. Third, lack of precise data for enforcement or conservation action. We will provide geotagged drone footage and report with severity classification. Then, fourth, inability to monitor ecological sensitive border zones consistently. We will implement transponder satellites monitoring and a shared cloud-based alert system. Fifth, insufficient human resource for continuous forest patrolling. We will automate surveillance with satellite-detected hotspot and drone-assisted area inspections. Sixth, poor coordination between India and Bangladesh in Sundarban conservation. By establishing shared protocols, data dashboards, and joint response plans using cloud technology. So here are our research and reference that we took from the internet, and we have put everything that are facts only. Uh, that's it. Hence, it's the team ad hoc fusion that proposed the idea AI-based deforestation detection system for mangrove diversity and many other biodiversity. If this particular is a success, we are from NIST University Berhampur, Odisha. Here are the team members: G. Om Prasad Dora, V. Durgeshwar Rao, and this myself, Amrit Kumar Prasad. And hence, thank you for listening.